Hello, children. Yes, in the today's class, we are going to discuss about a very important concept that is arithmetic progression. Correct? Yeah. So now let us see what is arithmetic progression. Before that, don't forget to subscribe my channel, that is Ignite Math ARP. Okay, yes. So arithmetic progression. Now before we actually go to the concept of arithmetic progression, let me give you some examples over here. I just write some of the numbers over here. I want you guys to guess the next to two numbers, right? So yeah, the first number is 2, 5, 8. I want you to guess the next two over here. Next one is 2, 6, 18. I want you to guess the next two numbers. Next one is 1, then 4, then 9. I want you to guess the next numbers over here, and also here I'll be writing a number 1, 8, minus 10, 4, and minus 6. I want you to guess the next four numbers. Okay, so here if you observe carefully, the next number here is, can you tell me what is the next number? See here, to obtain the next number, I'm adding plus 3 here. To get the next number, I'm adding plus 3 to the existing number. So I can say that next number is 11 over here, because 8 plus 3, 11, 11 plus 3, 14 is going to be the next number. So over here, I have multiplied each and every number by 3. See here, again I have multiplied it by 3. So next number over here would be 18 into 3, that is 54. So next number would be 54 into 3, that is 162. Here I have written 149. So means what? It is 1 square, it is 2 square, it is 3 square. The next number over here will be 4 square, that is 16. And next number over here will be 5 square, that is 25. But over here I get, okay, stuck over here. What is the next number? Why it is so? Because whenever I'm writing this set of number, I am following certain rule or certain logic or certain pattern, I can say, where here there is no rule or no pattern. Clear, children? So the set of numbers whichever are written by following certain pattern or rule, they are called as sequences. Okay, they are called as sequences. Over here it is not a sequence, it is not a sequence. Clear, children? Right. So now if you consider the first one, see, 2, 5, 8, 11. So in a sequence, when one number is written by adding certain constant number to the previous number, or by subtracting some constant number to the previous number, or when one number is written by multiplying the existing number with certain constant number, or by dividing the existing number with a constant number. Okay, so in such cases they are called as progressions. They are called as progressions. So especially whenever some constant number is added to the existing number, or some constant number is subtracted from the existing number, then it is called as a arithmetic progression. It is called as a arithmetic progression. Or when a constant number is divided by some number or multiplied by some number, then we call it as a geometric progression. We call it as geometric progression. So in the today's class, we are going to learn more on arithmetic progression. Clear, children? Okay, I'll just take this AP, arithmetic progression. In short, it is called as AP. Right, so I will just take this AP as the reference AP. Don't worry about the geometric progression, children. Okay, I'll definitely make a video on geometric progression, or once again I'll come live to explain about the geometric progression. Clear? So now let us deal much with the arithmetic progression. Now I take the numbers 2, 5, 8, 11, 14, 17, 20, 23, 26. They all are called as the terms of the arithmetic progression. So first one is denoted by A, which is also written as T1. Second one is T2. Third one is T3. And the fourth one is T4, T5, T6, and so on. This is T7 and T8, T9. Okay, so if I'm asking you to find out the T10, that is term number 10, you can just add the common difference 3 to the T9 to get the next number. Suppose if I ask, how can I find out the 50th term of this AP? How can I find out the 100th term of this AP? I cannot keep on writing the different terms of this AP, right? I need to have some formula, some logic to find out the required term of given AP. So I'm going to derive a formula for the same. Now, if you observe over here, the difference between each term, that is nothing but T2 minus T1 if I do, or T3 minus T2 if I do, or T6 minus T5 if I do. Okay, all of them are called as a common difference. Whatever I get, that is called as a common difference, and it is constant for the given AP, which is denoted by D. In this cases, the common difference is 3, because 5 minus 2, 8 minus 5, 11 minus 8, anything for that matter, 26 minus 23. In all these cases, we are getting 3 as the common difference. Clear, children? So now I'm just writing 2 over here. To write 5, what I do here is 2 plus 3. Okay. To write 8, what I do? 2 plus twice of 3. To write 11, what I do? 2 plus thrice of 3. Clear, children? So here, if I generalize, this is A, and over here, if you observe carefully, this is A plus D, and over here, if you observe carefully, A plus twice of D, and over here it is A plus thrice of D. Now I just keep the first term as A itself. Second term can be written as A plus 2 minus 1D, because just simply 1D means what? I can write it as 2 minus 1D. Clear? So over here I can write this one as A plus 3 minus 1D. Okay, so over here I can write this one as A plus 4 minus 1D. If you observe carefully, children, this is term number 1, this is term number 2. Since it is term number 2, 2 minus 1 into D. So this is term number 3, that's why 3 minus 1 into D. So this is term number 4, that's why 4 minus 1 into D. So if I am writing 50th term, can you guess what is the next number? What I would write? Okay, that would be A plus 50 minus 1 into D. That will be the 50th term of this AP. So if I am writing the nth term or the last term, if I am writing the nth term or the last term, then I can say it is going to be A plus C. For second term, it is 2 minus 1. For third term, it is 3 minus 1. For 50th term, it is 50 minus 1. So for nth term, obviously it will be n minus 1 into D. So this is the formula what actually we use to find out the nth term of the arithmetic progression. Okay, so the formula Tn is equal to a plus n minus 1 into d can be used to find out the nth term of the arithmetic progression. Clear children? Say for example, if I want to find out T9, look at this, it is a plus 9 minus 1 into d. So what is a for the reference AP, whatever I have taken? It is 2. 2 plus 9 minus 1 is 8 and d is 3. So I can write this one as 2 plus 8 into 3 is 24. So that is equal to 26. So T9 is going to be 26. Look at this. Our T9 is going to be 26. Is that clear children, all of you? Any doubt over here?